Hello everyone, welcome to the channel. In this video we are going to have example 4, example 5 and example 6, which is given in page number 101 onwards, and it is before your exercise 6.2 for chapter 6, lines and angles. So here we have the example 4. Let us understand what is given in the question. So they are saying that in figure 6.24, if PQ, here it is PQ line, is parallel to RS, is parallel to RS line, here it is RS. So we should write down also PQ is parallel to RS. Angle MXQ is given. M, this is M, XQ is given as 135 degree. Angle MXQ is given as 135 degree, and angle MYR, M, Y and R. This point is R and Y. MYR is given as 40 degree. Then find MXMY. XMY. We need to find this. This angle is unknown. So let us solve this question. So these are the things which are given. So we need to draw a line, that is a construction we need to perform. So here a line AB we draw, line AB passing through point M. So we have drawn this line AB. So we will write down the construction. Draw a line AB parallel to line PQ through point M. So now we are having that AB is parallel to PQ and PQ is parallel to RS. This is already given, and this one is done by construction. So if we compare these two, we can say that AB is parallel to RS. Now you have angle QXM plus X angle XMB will be equal to 180 degree. It is what we see that if a line PQ is parallel to line AB, so we will see that the interior angles on the same side, interior angles on the same side of transversal the sum is supplementary. That is what we have written. This angle and this angle is added together, it will be 180 degree. Angle MXQ is given as 135 degree. So 135 degree plus angle XMB equal to 180 degree. Then angle XMB will be equal to 180 minus 135 degree. If we subtract these two, we get as 45 degree. Angle XMB is given as 45 degree. Now AB is parallel to RS. AB is parallel to RS. So in this we see that AB, this line AB and RS are parallel. So we see that RYM RYM is equal to BMY. These two angles are your alternate angles, and these two alternate angles are equal to each other with the reference of theorem that when these two lines are parallel and whatever the alternate angles they will be forming, the alternate angles will also be equal as per the theorem. So as it is given that angle MYR is already given as 40 degree, then angle BMY will also be 40 degree. Now if we add these two angles, angle XMB plus angle BMY, we get angle XMY that we need to find. Here XMB is 45 degree, BMY is 40 degree, so we get XMY 40 plus 40 80 85 degree. So 85 degree we get as angle XMY. So in this way we solve that question. Now we can move to example 5. Here we have example 5. Let us understand the question first. Here the question is, if a transversal intersect two lines such that the bisector of a pair of corresponding angles are parallel, then prove that the two lines are parallel. So this question is given, so we need to draw the diagrammatic representation that if a transversal intersect two lines. So let us see, these two lines are there. Now these two lines are parallel or are not parallel. This is not mentioned. So it is line PQ and another line is line RS. Now a transversal line used to intersect these two lines. The transversal line is AD. Now these two lines are parallel to each other, that is not given here, such that the bisector of a pair of corresponding angles. So here let us say this is a corresponding angles, this pair is corresponding angle, angle 1 and angle 2. A pair of corresponding angles, we can see angle 1 and angle 2 are a pair of corresponding angles. Now for these corresponding angles, angle bisector, two lines bisector of a pair of corresponding angles are given. So we need to draw a bisector. So it is BE, angle bisector for ABQ. Here another line, this is also an angle bisector, CD for BCS. So we see that BE, line BE bisect angle ABQ, and line CG, this is G, line CG bisect angle BCS. When it bisect, we can write down that angle ABE is equal to angle EBQ. When line CG bisect angle BCS, we can write down angle BCG is equal to GCS. Before this, they have also given that these bisecting lines, line BE is parallel to line CG. Line BE is parallel to line CG is also given in the question. What we need to prove? We need to prove that PQ is parallel to RS. That is the question we have to solve. Now, whatever the things which are given, we will continue with this. Now, in this, we can write down that angle ABE is half times of angle ABQ. Similarly, angle BCG is half times of angle BCS. So as BE is parallel to CG, so if I draw these lines like in this figure here, BE and another line which is given is CG and a transversal line AB or AD. So these angles are corresponding angles. So these corresponding angles are equal. If these two lines are parallel, then the pair of corresponding angles, that is angle ABE and angle BCG, are corresponding angles, and these corresponding angles are equal to each other depending on corresponding angle axiom. So we can use this AB, you can be written as angle half of angle ABQ. BCG can be written as half of angle BCG. BCS, not BCG. So half and half get cancelled. Then A B, it is not ABQ, it is ABQ. ABQ is equal to BCS. So we get it down at ABQ. ABQ angle is equal to angle BCS. So on the basis of this, these are corresponding angles, and if we find that these corresponding angles are equal, then we can say the line PQ is parallel to line RS. The converse of corresponding angle axiom will be written here. So it is due to converse of corresponding angle axiom. So this way we come across this particular question. Now we are with next example 6. In the figure, AB is parallel to CD. So a figure is given here, a line AB is parallel to CD and CD is parallel to EF. Another line is there, it is EF. Also we can see that EA is perpendicular to AB. EA is perpendicular to AB. So here it is 90 degree. If BEF is given as 55 degree, so BEF, so we need to join this, and this line is passing through point D. Angle BEF is given as 55 degree. Find the value of X, Y and Z. That is a question mark. In the figure, this angle is angle Y, this angle is angle Z, and the angle X is here, angle X. Now we see that if it is given that line CD is parallel to line EF, if these two lines are parallel, then we can say that the angle DEF plus angle Y is 180 degree, because the interior angle sum on same side of transversal is 180 degree, is supplementary. So angle Y is equal to 180 minus DEF. DEF is 55 degree. So 180 minus 55 degree is 125 degree. So angle Y is 125 degree. Now we also see that line AB is parallel to CD. If line AB is parallel to CD, then or we can also see that if line AB and CD are parallel, yes, it is given. If AB and CD is parallel, then the angle DEF plus angle X equal to 180 degree. So it is 55 degree already given. So it will be 55 plus angle X equal to 180 degree. Angle X equal to 180 minus 55 degree. Then angle X will also be equal to 125 degree. Now AB is parallel to CD and CD is parallel to EF. So therefore we can say that AB is also parallel to EF. AB is parallel to EF. It means that angle EAB plus angle FEA is 180 degree. That is what interior angle sum on the same side of transversal is supplementary. So here the angle EAB is 90 degree, then angle FEA is angle Z plus 55 degree equal to 180 degree. Then we can find angle Z as 180 minus 90 plus 55, so it will be 35 degree. So in this way we come across about the solution, and here we are using different theorems and axioms to solve these questions. In the next coming video we are going to have our exercise 6.2 for the chapter lines and angles.